Hello and welcome to our workshop about IoT. My name is Christoph Henrichs and I work at Technikum Wien. At Technikum Wien Academy, our academy for continuous reskilling, upskilling for tech and digital companies. And it's my pleasure today to introduce to you this workshop. Why do we talk about IoT and the Internet of Things? You know, it seems to be a tech topic in a business event. We thought the title of this event is The Future of Digital Business. And of course, the future of digital business belongs to those who own or produce data, and of course, who know how to handle it. So that's actually what IoT is about. A few years ago, of course, if you remember, the Internet of Things or buzzwords like Internet of Everything, Connected Everything used to be like quite a hype. And to that extent that the connected fridge used to be a running gag on tech conferences, I must say a long time ago, but that's how many remember IoT, and that's how it goes. After a hype, technologies and especially their application and solutions basing on that technologies develop besides the spotlight. And I must say, most of all these hypes develop pretty well, you know, after the hype. Nowadays, IoT is the perfect field for digital business. And of course, it's one of our favorite domains at Technikum Wien. So let me introduce to you our first speaker, Harald Winkelhofer, our head of IoT, of our IoT lab at the University of Applied Sciences, Technikum Wien, and of course, the head of IoT at Technikum Wien Academy. And by the way, just to make a little ad, he is as well the host of our upcoming IoT webinar at Technikum Wien Academy. Harald, let's begin with a crucial question. You know, how finally we have all these data, how to use these data for meaningful and innovative solutions?
Yeah, hello all together from my side. Great question. I prepared two scenarios and to answer your question. When we think about the music industry, and we go back around about more than 100 years, in the year 1877, we had two guys who invented the phonograph. One of them is already known, maybe, Mr. Edison. And what did they have? They had vinyl. I don't think it works. I think now I'm online. So when we think about the music industry and we go back for more than 100 years, we had a scenario where music was the data and vinyl was the data carrier. When we then walk a little bit in the past, we came to the tapes. Nearly 100 years later, in 1958, the Radio Corporation of America invented the tapes. Again, music was the data. The data carrier changed into a magnetic band in a tape. When we step forward into 1982, we had the development of the compact disc from Philips, Polygram, and Sony. And the tapes and vinyl was history. But still, music stayed the data carrier changed. Then when we make a step forward, we had a great invention. In October 2001, we had the iPod from Apple. There were 5 gigabytes hard drive in our pocket. There were 1,000 songs in our pocket. MP3 was the format for listening to music. But again, music was the data carrier changed to that innovative hardware. And then for me, the question is, was this already a revolution? Was this already the end of the story? Did that already change everything? And to my opinion, we see the real revolution 30 years later, after the compact disc as a digital data carrier was invented. In the year 2008, we saw Spotify and other streaming services coming up, and they were game changers. Still, music was the data. The data carrier changed into several hardware where this software could be installed. And additionally, and that was the game-changing aspect for me to answer your question, that is a new business model that came up. So it was not only the digitalization and the further development of hardware that took place. In that case, it was real digital transformation. So my first answer to your question about these meaningful and innovative solutions, how to use data, one answer from my side is digital transformation is a meaningful and innovative solution to use data. And in the scenario that I explained now, we had old data, let's call it old data, it was still music. But the environment around changed through digital transformation, and also the business model and the whole value chain, everything changed. The data still stayed the same. And then let me give you a second example in my introduction to answer your question. Let's move to another industry. Let's move to the automotive sector. We all know the good old cars. We also all know such scenarios where we as human beings with our sensors, with nose, with ears, or with eyes, can recognize if a car has a problem. And if our human sensors recognize that a car has a problem, it's mostly too late. Currently and today, thanks to digitalization again, we have the situation that, let's say, most of the cars, especially old cars that you can purchase now, are connected. They all have sensors integrated, a lot of different sensors, and they are all connected. They are connected to whoever and to whatever. They are connected to the internet, they are connected to the dealer, they are maybe connected to Google. So in the field of the automotive sector, such kind of Internet of Things value network based on a lot of sensors that are implemented in cars, based on networks, mobile networks that give us the possibility to build connections, to connect things or human beings. We have a complete new situation in the automotive sector. And by the way, this IoT value network is also introduced in the webinar that Christoph told you from the Technikum Wien Academy about IoT. What's happening in the future with cars? They will be able to drive alone. Self-driving cars will be a topic for sure. Maybe for me, it's not really cars, but currently they are introduced as cars. The flying cars are maybe a topic. And all these things and these game-changing developments are possible thanks to the Internet of Things. And in this second answer that I want to give you about meaningful solutions around data, in that scenario, I want to give you the answer that collecting new data, thanks to different sensors, bridging them with things and human beings, thanks to telecommunication networks, we have, to my opinion, definitely the Internet of Things as a meaningful and innovative solution. So digital transformation on the one side and the Internet of Things on the other side are, for me, great possibilities and can build the bridge for meaningful, innovative solutions. And now I'm glad that we have two of our partners here in our workshop, and they will introduce us my currently favorite cases from the world of IoT, especially in Austria. And so I can give the word, first of all, to Christoph Köstler from A1, and then followed by Michael Lagan from Magenta. Thanks for joining us, and Christoph, have fun.
So, hello everybody. Welcome to this interesting session about floating phone data. That's one service where the mobile phone is the connected device. And in the next few minutes, I will present you some use cases, some interesting insights about how we can use this floating phone data to support several industries. My name is Christoph Kössler. I'm product manager in A1 and responsible for IoT and analytic services. So talking about floating phone data, it's about analyzing human mobility at scale. Why is this so? You see, the floating phone or the mobile phone represents the human mobility. So just some brief insights about the background. There are about 6 million mobile phones connected to the A1 network. How do we get this floating phone data? If a mobile connection is established or teared down, the mobile phone is sharing signaling data with several cells, with several antennas, and therefore we can triangulate and we can calculate the location of this mobile phone with about 50 to 100 meter accuracy. And as this service is running permanently, so 24 hours a day, 365 days a year, we have a permanent data feed. There are several billion data sets each day. So there is nationwide coverage. And one advantage of the floating phone data is that at A1, the data is available even backwards. So we can even look in the period before the lockdowns and the travel restrictions. And just to be sure, the entire data used for floating phone data analysis is anonymized, and this is certified by TÜV. So what are we doing? There were several services running with this floating phone data. This is done in cooperation with our subsidiary, the Invenium Data Insights, and we generate trajectories based on this location data. And these trajectories, these anonymous trajectories, can be matched with respective customers' use cases. And the results are presented to the customer in an interactive dashboard. The results are projected to the entire Austrian population, plus the tourists. So everybody, every phone which is moving in Austria. That's mobility in Austria. But there's a minimum granularity of 20 users per output value. This is an additional privacy topic. So if we monitor these location data and these trajectories, we monitor it from a stationary stay in the morning when you are at home. Then you have several activities like going to work, you're shopping, you have some leisure activities, and then you are at home again. And if we match this with customers' use cases, for example, the first use case which I will present you is about retail. So for retail, this floating phone data is like a digital market research. How can you use it? For example, to optimize your campaigns. So you receive several data like the number of passerbys, the dwell time of customers in the main street or in your shopping center, the demographics. You can see the catchment area where the people come from to your main street. You have interactions with other locations like the city center or the train station. And you can also measure the performance of campaigns before the campaign and afterwards. And here now an interesting example. This is from Vienna, from the Maria-Hilfer-Straße, a very prominent shopping street. So if you look in the upper left, this was in May 2019, before COVID. So there were about 130,000 customers each day. And if we take a look at the blue bar, we see that after 8 in the evening, there were still plenty of visitors at Marie-Hilfer-Straße, because there are many, many restaurants and theaters and so on. If we take a look at the next graphic, we see that 1 year later, in May 2020, this was just shortly after the first lockdown, so the shops were open again. That's why we see a peak in the usage figures in the afternoon when people went shopping after work. But there were only 1/3 of customers at the Marie-Hilfer-Straße. And if we take a look at the blue bar, as the restaurants were closed, there were just 1,500 customers in the evening. A year later, if we take a look at the lower graphics, at the end of the lockdown, 2 weeks ago, there were just 20,000 visitors at Marie-Hilfer-Straße, and also almost nobody after 20 o'clock. A week later, at the 7th of May, when the shops were open again, the customer figure has doubled to 45,000 customers, but still restaurants are closed, so there are hardly any visitors in the evening. And that's something where the retailers, they can really monitor what's happening at their main streets, what's happening before their stores, and how they can use this data, for example, for their campaigns to win back lost customers. Same is possible in the tourism industry, where we can monitor point of interests, the catchment area of this point of interest. We can monitor the COVID impact before the travel restrictions and afterwards, and so on. And here I have provided an example from the city of Salzburg. In January 2020, there were almost 1 million of customers, almost 1 million of visitors in the city of Salzburg. And 1 year later, during the lockdown, there was just 1/5 of visitors visiting Salzburg. And if we take a look at the bars in the middle, we see that the second bar from the left, which represents the demographics between 20 and 30 years, this group of visitors was affected most by the lockdown. So you can also get the demographics, and you don't only have the counts, but you also have demographics, catchment area, a nation split in the graphics below, where we can see which nations are dominant at your location, and you can monitor the effect of the travel restrictions. If we take a look at the catchment area of the city of Salzburg, we see that before the lockdown, there were visitors from nearly entire Austria, but during the lockdown in January 2021, the catchment area has decreased. We can do the same for the event industry, where we can provide insights where the customers come to watch these events, the dwell time, how long they stay. They also need this to organize, for example, package services, shuttle services, or just a simple thing: where is the best place to place a kiosk or toilets? And you can also monitor interactions, like interactions with the city center. You can calculate overnight stays, and so you know the regional value of an event. And here in this last slide, I will provide you a comparison of the two ski races. The left one was in Kitzbühel. It was about midday. So we see there is a peak at the second run of this slalom. And then there is a continuous decrease of visitors until the evening. And the nation split, if we take a look at the lower graphic, we see that about 1/3 of visitors came from abroad. If we take a look at the right example, this was a night slalom. Here we had about the same number of visitors, but they arrived shortly before this night run, and after the race was over, they got back to their cars and drove home. And as this night run isn't that prominent like the Kitzbühel race, also the nation split of visitors from abroad is a little bit lower. So in the end, what I tried to show you in these last minutes is that floating phone data can provide valuable insights for several industries. That's a service up and running, and we are really glad that today in our IoT world, such a service is available to the market and to our customers. Thank you very much. Then I will hand over to our next speaker, to Mr. Lagan. Thank you.
So thank you very much for the introduction, Christoph. It's a pleasure to be here today, and everybody's talking about data is the new oil, but the most important thing is how to turn this oil or this data into information. And therefore, I want to talk today about narrowband-driven air quality sensing solutions as a use case in public buildings. My name is Michael Lagan, and I'm the head of IoT and Smart Building Sales Department at Magenta Telekom in Austria. Well, at the beginning, let's talk a little bit about technology. We heard today about LPs, CDs, mobile phones, and even floating phone data, but we haven't really talked about what's one of the major transmission technologies if you talk about radio networks on the telecommunication side, and that's where I want to start with today. From Magenta perspective, we are running different technologies for sure to cover different needs of different use cases. Every use case has their own requirements for example, for transmission technologies. This could be the LTE-M level, which is a subnet of the typical LTE technologies, a mobile broadband that everybody knows on his phone. And for sure, for special use cases, there is a technology like this narrowband IoT, which will go more deeper into my discussion today, where we're focusing especially on solutions that are, as you can see here, on sensing solutions, condition monitoring, and everything that don't really have very critical data, but a lot of data from different measuring points with a very low amount of data sizes, for examples. Let's go a bit more deeper into this. I have here a small split what are the differentiations between those technologies. If you think about LTE-M and narrowband IoT, there are some differentiations which are sometimes crucial for different use cases. And especially if you think about mobility, where you have, for example, seamless cell handovers, that means that your devices can easily move in an area without losing the connectivity and simply reselecting a cell while moving. The other thing is as well the size and the speed of the transmission itself. Narrowband is really reduced to very small amount of data that is transmitted on a very regular base, but this doesn't mean that it's on a minute base, but probably on a, I don't know, 1 hour, 2 hours, 5 hours, or even once a day. And the other very interesting thing, especially in narrowband use cases, is the in-building penetration. That means due to the signal, the transmission can even be guaranteed within buildings, or they can reach the devices deeper into a building, which is very important, especially if you think about sensing solutions that are, for example, inside, maybe in a cellar or somewhere deeper into a building. And the other very important thing, if you think about IoT and often just battery connected devices, or the battery powered devices, it's for sure the lifetime of the battery. And due to technologies like EDRX, which is technology to support or enlarge the battery life, this is something that narrowband LTE can deliver to those specific use cases. And if you sum those technologies up, you can talk here about low power wide area technologies. And this is something that is really important for nowadays use cases for sure, besides other technologies that everybody knows, like, for example, LoRa and stuff like that. Well, but now let's start to talk about the use case itself and start with COVID. Yeah, COVID changed everything. If you see the picture, how the meeting rooms and the classrooms and everything in the past looked like. A lot of people really stick together in the room. You have to share a table, so it was always crowded. Nowadays, nobody can imagine that anymore. You sit in a room and you have a lot of people, maybe someone in future, but nowadays it's really hard to think about such a solution. Therefore, we have prepared a specific solution for schools, in that case, public buildings, to solve those special requirements they have due to ventilation, due to how to handle the class sizes, due to the thing that you need to have a traceability, how was the ventilation made, and there are different steps schools or public buildings need to take to solve those big problems. So, I mean, too many people in a classroom, for example. Yeah. And this will lead me to the solution, to the device that is collecting the data. It's not a phone, it's an IoT narrowband driven device that is going to measure, collect, transmit, analyze, and finally, hopefully act. And this is the important thing in the entire IoT value chain. From measurement, you see in that case, it's CO2 temperature and air pressure. If you combine it together, you have an CO2 sensor, air quality sensor that is collecting data, storing data. It could be handled like a small edge device that is having thresholds on the device itself and deciding, for example, when a threshold is reached, that the data will be transmitted. Maybe a visual or acoustic action will be triggered. Finally, the data, and Christopher showed it, there's always a platform in the back, so where the data will be shown, collected, and finally analyzed. But at the very end of the day, and that's what I'm saying at the beginning, is how to turn data into information and in action at the very end. It means if I have that, I have collected it, I have amount of data, I know that there is a bad air quality in the room. What do I have to do? How do I have to act? And that's the most important thing that we need to learn out of data. And if we take this use case, especially on a public building, let's think that that's the office of the mayor, for example, or it's the classroom, or where you have a lot of people sitting around and the teacher, and we have one of those devices, for example, into each of those rooms. You can say, hey, okay, there is something happening in this room. There are too many people. The air quality is going down. So how to act? The device, for example, if you think now it's calculating its stuff on the edge and deciding to inform somebody. So we trigger something. It could be a data session transmitting something, or a simple acoustic or visual signal that is informing the person in this room to, for example, open the window. So it's a very simple example in reality here. But if you go a little bit more deeper and think about, hey, there's a room with pupils inside, the teacher is educating. So maybe not thinking about to open the window in a proper time, like 30 minutes, which is more or less some guidelines from the government, and the air quality is going down. So what could happen? How could such a device and the data help us or help the teacher? In reality, the threshold is reached, data is transmitted to the platform. The platform is going to analyze and to set an action. And this action could be, for example, if you have a connection to different other systems, it could start an automated ventilation. It could start the AC or any other device just to help to prevent, for example, to get a worse air quality, to higher the risk of, for example, infections and stuff like that. So this is a very simple example, but the thinking behind is how to process and how to get information out of the data itself. If we think about what's the values, for example, such devices could generate, it's very simple. It's like gathering information on an automatic way. If it's real time, it's even better. So maybe other technologies can support it more or better than its narrowband is doing. But this is one solution. You can have an alarming, for example, just to prevent, no matter what kind of alarming it is. The most important thing is collaboration and connection to other platforms. That means platforms that could benefit from the collected data and use that for their own automated working, like, as I said, ACs, ventilation systems in that case. And for sure, collection and the transformation of the data and turning it into knowledge or in long time knowledge. In reality, it means you have a better air quality in the room. You lower the risk of, for example, infections for the pupils. You have a traceability in case of COVID infections or clusters, for example. So you can guarantee, as for example, a school, that you have done the most possible thing is to open the window in the right time when the air quality is going down, and then the risk of, for example, COVID infection is rising. And for sure, it's very important is to understand how, for example, the amount of people in a room are affecting the air quality. So you can start steering stuff better. You can enlarge the class, the amount of people in a room, or you need to lower it because the air quality is really getting worse after a short time of period with more people, or it's not affected. So there are different possibilities. And at the end of the day, it's always the thing how to learn from it, not only the generating and getting the data, but always the how to learn it, how to learn from it. So that's it. Thanks a lot from my side, and thanks for listening.
Yeah, thanks a lot, Michael and Christoph and Harald. So it's time for Q&A. Let's see what we have. There's one general question. How do you handle security issues? Maybe my suggestion is to break it down to the team level, maybe. So how many people are working on security, or can you just measure that just to give an impression of that? I think it's a very important topic, of course, but sometimes, unfortunately, IoT or topics like that are only in the media on the front page when it comes to security breaches. So let's talk about that and how you handle that beforehand. Maybe who wants to begin?
Christoph, I don't know. Do you want to start?
Yeah.
Well, from my side, there were several departments in A1 dealing with security. This is the IT security, the network security, and so on. But I can only talk about the service which I have presented to you. Security in this term, data security and data privacy. This is very, very important. That's why we have implemented an anonymization of the raw data, which is certified by TÜV, that it is really absolutely not possible to track a respective customer, that to get any insights to a respective person. This is by design technically not possible, and that's very important. If we provide such services, we have to take care about data security and data privacy. That's really, really, really a very important issue by design.
Okay, thank you. So maybe that answers the second question as well about GDPR. One could think that GDPR made it more difficult for projects or products like that. But yeah, is that right?
We don't say that it did make anything more difficult, because regardless of the GDPR, that's what we are responsible to our customers, that we don't take personal information for such services. So this is only done on an anonymous level. And we are really glad that we are living in a country with a GDPR. But nevertheless, also without the GDPR, it would be that we would handle it on the most secure way.
Okay, and then what I see next? IoT, especially when presented by huge telecommunication companies, sounds like a lot of hardware infrastructure and so on. Do you have some advice for smaller, medium-sized companies, how to begin with these projects? You know, the projects you presented were quite fast, I guess. You know, you did work on that for years and years. But do you have yeah, kind of advice for smaller companies who want to join that business?
I will try to answer that question. I mean, it's always the matter what's your business case and what the pain you want to solve in reality with your product. But it's always at the very beginning the decision of what kind of transmission technology you want to go with, what's the right one. If it's a mobile technology, like I presented before, it's something like as said Laura as well. But you need to put a lot of effort on understanding how this mobile technology will or can affect your entire product and product development. So you need to really start, not put that at the very end. What a lot of companies or entrepreneurs are doing, they're trying to take care of that at the very end, but you should start at the very beginning because it's influencing a lot. So it's very important to do this, and there are a lot of offerings as well from Magenta side, some advertisement, just regarding the selections of modules and stuff like that. So it's very important, anyways, and this is one advice I can give at that stage. So don't be too late with that.
Yeah, just begin with the first step.
Maybe from my side also an input regarding that. This is always these words like Internet of Things or big data, they are always combined with that costs a lot of money. Maybe if I implement that in my company and I'm a small medium enterprise, for example. But to my opinion, that needs not to be the case. There are many small available solutions. I think especially that what Michael introduced us is a thing that a coffee shop or a restaurant, a small one, can use. And it's nothing like a big industrial project. And these words like Internet of Things or big data are mostly in our minds connected to big investments, long projects, and complicated stuff. And especially, I think the Internet of Things solutions can be also related to small budgets and short-time implementations.
Okay, next question would be, have you thought about data ownership and incentivizing the producers of the data? So maybe your customers.
Well, I think this is an interesting question, but nevertheless, concerning floating phone data, this is an operative technical data used in the network to provide the best connectivity between the mobile phone and the mobile network. So this location data is necessary to achieve a connection, technically speaking. The other thing, what you mentioned is that this data gets monetized into a commercial service. But as this is data which is collected in the network with several million mobile phones, just think about the business case. This is nothing like you could compare with, let's say, an advertising service where I say, okay, if you agree with this kind of data usage, you have a respective benefit. Because, for example, the advertising industry is really a big issue. So this is just providing a service out of the movement information which we receive at our cell infrastructure. But this is nothing where you can say, okay, if you as a customer, if you agree to a respective service, then you get incentivized with it. But on the other hand side, if you're a customer and you say, I don't want to participate in this, you have the possibility of an opt-out. So it's a fair game for all of us, for the customers, for A1 as a, let's say, a service provider, and for the customers who need this data to optimize their business.
Okay, thank you. There's quite a tech question, quite an next level nerd question, and I mean that in the best sense. What is your opinion putting data on a blockchain and on IOTA especially? Yeah, you know, it's actually quite easy to think of blockchains focusing on IoT like IOTA. Yeah, so it's not that nerdy in fact, actually. Yeah. Have you thought about these blockchains focusing on IoT?
From my perspective, it's depending on the use case. I mean, it's not, I wouldn't put everything on a blockchain, or especially in IOTA, but there are different cases that I would say it makes sense to do it for sure. Yeah.
Yeah.
I don't know how Christoph's opinion on that, but I guess it will be more or less the same.
Well, basically, we say we don't share raw data. We just provide analytic reports. And so talking about analytic reports, there's nothing where we say this is a topic of blockchain. That's just service reports, results, market insights, and so on.
Yeah. Harald, question to you. What's, in your opinion, what are the most interesting domains or sectors, businesses where IoT could be used? Maybe like energy or mobility, or
maybe I start with two, which is just private opinion. The one is I would love to see the traffic lights connected to cars and optimize the traffic, especially in cities or around cities like Vienna. I think there's a lot of potential in optimization, not only of traffic, also focusing on our environment and the climate goals we have. That's one thing, maybe. And so the keyword for that could be smart cities. And the second thing is at home, smart home. For me, an area even coming from the gardening, that the sensors react depending on rain or sun, that we have great flowers in our garden, and coming to indoor services regarding the lights or whatever. So smart home is also, for me personally, one of the favorite topics. Smart cities and smart homes, I would add here to that question.
Yeah. So if you don't want to add something, if you want to add something, Michael and Christoph, just tell me. Don't want to interrupt anybody, but next question would be, that's a good one. Is there any device available to obtain data out of old machines? I suppose maybe my old toaster. I don't know.
Yeah, maybe I try to answer that question. I mean, the IoT market is massive, so I'm pretty sure that somewhere on the globe there will be a company exactly allowing to do that. But the base for that is that your machine can be connected somehow. So if you're talking about industrial machines doing whatever, producing and stuff like that, there will be a bus, something you can connect it, or a PLC, so at least you will be able somehow to gather the data and maybe transmit it. But it's always depending on the base of what your machine can provide you, or at least at the connections that they have.
Yeah, guess the black box has still not been invented, but just to press button and produce data, it's still quite difficult.
That's true.
Yeah, next question. What are the most exciting IoT projects you're looking forward to? Not just in your company, but maybe we could add that question as well. Maybe if you can talk about your current projects and your favorite project ever.
So I will start again with that. we have I don't, it's really hard to say there is a favorite project or there is something very exciting. It's exciting to see or to support companies in their growth at the beginning. Yeah, it's not like just giving connectivity or providing IT connectivity. It's more like a consulting and thing that is to support companies to be able to connect their devices. So there are different use cases in different branches, and there's always a differentiation, even if it's a similar thing, but the people are handling stuff in a different way. And this is something that is very interesting, not only to me, but also to us as a company, to see how different use cases are working out. So I could not mention a very exciting project or something that is that I'm really looking for. I mean, IoT in the city ecosystem, something that is very interesting. Harald mentioned it already. There are a lot of possibilities for IoT to connect cities, from smart streetlights up to up to sub-metering issues, up to green walls and stuff like that, parking solutions, waste management, a lot of possibilities in cities. So this is a very broad area.
May I add something? Personally, I also can't name a respective project where I say this is my favorite. But what is really exciting is there were some companies who just use IoT services, let's say, to monitor something and to analyze this data on an intelligent platform. And there were other companies who really changed their business, because IoT is an enabler for digitalization. And it's very exciting to see that when customers are changing their business, for example, from just selling machines into providing services. And this is only possible if you can monitor the utilization of a machine with IoT. This is exciting to see this change in how businesses work.
Okay, thank you. We don't have any question from Slido anymore, but that's just my chance to ask quite typical question coming from a university. What skills do you need in your IoT teams? You know, what kind of specialists? What do they have to learn? What do you think? What's the most important thing? What are you looking for what kind of employees and team members and so on, in terms of education and their background experience? Do they have to be data specialists or hardware or?
Well, I think it has to be a good mixture of all, because on the one hand side, you need data scientists. On the other hand, you need specialists of respective businesses. You also need let's say, the typical IT engineers who can provide a front end, a back end, and so on. So I say this is a multitude of skill sets which is necessary to provide end-to-end services, not just for a pilot, but really for commercial services with high usability, with 100% availability, with security, and so on. So there's really a big business field in the technical, in the legal, in the commercial, in the user experience topics, but it's not possible to drill it down to one respective skill set.
That's true, yeah. I would say even curiosity and the open mindset, that would help a lot, you know, to develop people, and this is very important.
Yeah, I can imagine it's quite important to know about the different domains and use cases. You know, if you work in traffic or maybe some quite different field, it's quite hard to know about all these domains. Yeah. So I thank you very much for discussing, and especially our all the viewers. We don't know who actually was watching, but greetings to you all. And that's for now, and that's for our workshop here. It's my pleasure to just mention our little webinar at Technikum Commun Academy about IoT, and to wish you a nice day and especially a nice event. So that was it from us. Bye-bye.